Hello, my name is Egon Cholakian. As the year 2024 draws to a close, I deem it my duty to present a concise analysis and a well-substantiated outlook for the climatic and geodynamic trends expected in 2025. Based on the available data, we can assert with confidence that the coming year will witness a substantial intensification of climatic cataclysms, as well as an escalation in both the frequency and severity of geodynamic phenomena. Allow me to begin with the current situation. In 2024, we observed an unprecedented surge in the intensity of natural phenomena, approximately a 7% increase compared to the previous year. This exacerbation is evident in both the rising frequency and the growing potency of such cataclysms, which indicates mounting changes within the Earth's planetary system. However, what awaits us in the coming year is profoundly alarming. According to our calculations and mathematical modeling, in 2025, we anticipate a 12 to 15% increase in the intensity of natural phenomena compared to the current year 2024. I purposely emphasize the significance of these figures. They are unprecedented in our modern observational history. Of particular concern is the fact that we are not merely witnessing a linear increase, but rather a progressive, exponential acceleration of this deterioration. Without any collective human action, we have no basis to expect a deceleration or mitigation of this trend. The condition of the oceans has only worsened this year. This fact cannot be ignored. The accumulation of energy in the world's oceanic systems has reached an even higher threshold, which will inevitably reveal itself this winter through heavy snowfalls, record-setting low temperatures, and other aberrations. In the coming year, we anticipate the emergence of new climatic and natural phenomena, many of which will differ markedly from those which we have grown accustomed. We will likely confront more frequent instances of extreme weather events, novel combinations of natural catastrophes, and processes that lie beyond previously observed parameters. Likewise, the state of the Gulf Stream system, one of the pivotal elements of the global climate apparatus, is a cause for particular concern. It continues to slow, and the risk of its abrupt stoppage is on the rise. Such deceleration leads to profound transformations within the global system of water exchange. As atmospheric and oceanic interactions become disrupted, their imbalance grows more pronounced. Consequently, we face the intensification of hurricanes, widespread droughts, shifting wind trajectories, and acute temperature anomalies. These shifts threaten severe climatic and societal repercussions on a global scale. Esteemed colleagues, today I wish to draw your attention to a fundamental misunderstanding that persists within the scientific community regarding the current climatic changes. Thus far, the discourse has centered only on the search for new models to project climatic factors influencing the agricultural sector. I must emphatically warn, do not seek simplistic solutions. We are not dealing with a mere shift in seasonality, but rather with profound alterations to the entire climatic system. Humanity has long needed a radical rethinking of its scientific paradigms. Regrettably, our attention is often fixed on the consequences and thus on adapting to climatic cataclysms, instead of analyzing the underlying causes. To fully grasp the fundamental reasons behind these ongoing changes, it is essential to recognize that the foundation of our planet's climatic model is determined foremost by geodynamic processes. Allow me to draw an analogy from medicine. The atmospheric phenomena we observe are merely consequences, superficial symptoms, not the root cause of our planet's affliction. Just as symptoms do not determine the cause of an illness, atmospheric phenomena cannot influence geodynamic processes. We attempt to treat the symptoms, hoping for a resurgence of planetary self-regulation as witnessed before. However, the situation has changed drastically. For millions of years, our planet possessed a unique self-regulating capacity, a kind of natural immunity. One of the key foundations of this system is the world's ocean. Its role as a thermal regulator involves channeling excess heat from the Earth's interior and stabilizing the planet's internal processes. This mechanism helped prevent catastrophic shifts that occurred during the natural cataclysm cycles every 12,000 years, and with even greater intensity every 24,000 years. However, circumstances have now changed. Anthropogenic pollution of the ocean by micro and especially nanoplastics has negatively affected its ability to convey and redistribute heat. As a consequence, thermal energy has been accumulating in the global ocean and within Earth's inner layers at an unprecedented rate. This surplus of heat could become a powerful catalyst, triggering and intensifying geodynamic processes such as volcanism and earthquakes. Of heightened concern is the increasing number of deep-focus earthquakes within the mantle. These earthquakes occur at depths exceeding 300 kilometers or 186 miles. They are essentially massive intermantle explosions that release enormous volumes of energy, including heat. Not only are these events becoming more frequent, but their magnitudes are growing as well. On average, more than 15 deep-focus earthquakes with a magnitude above 4 occur each day. Even more troubling is that these processes are self-reinforcing. Each new event creates conditions that beget further intermantle explosions, hastening the overall destabilization of the system. Our mathematical model confirms this very trend. These processes initiate a chain reaction. Rising magma temperatures and increasing pressure on the Earth's crust stimulate heightened volcanic activity and destabilize supervolcano calderas. Even more significant is the fact that cyclical processes exert influence not only on the climatic system, but also on Earth's magnetic field and gravitational interactions, introducing changes on a micro scale. These minor micro-level fluctuations have far-reaching consequences for the atmosphere as a whole. Seismic activity continues to escalate, and the number of deep focus events is growing at a rapid pace. If anyone believes this increase merely reflects a greater number of sensors, they are mistaken. This phenomena is unfolding irrespective of the expansion of sensor networks or improvements in their sensitivity. Furthermore, public access to seismic data is steadily declining. Yet even the data that remain publicly available demonstrate an unprecedented rise in the intensity and frequency of earthquakes. Meanwhile, the process of natural degassing within Earth's mantle, evidenced by volcanic activity, continues to intensify. In this manner, the pressure accumulating deep within the Earth is only slightly revealed by volcanic eruptions. With regard to the overall dynamics of these processes, I can say the following. A characteristic feature of the escalation of various cataclysms remains their cascading nature. Periods of intensified activity give way to phases of relative diminution. However, it is crucial to note that with each new cycle, the duration of these quiescent phases diminishes while the intensity and frequency of activity in subsequent phases intensify. In other words, with every repetition, the process grows more vigorous and the periods of calm or reduced activity grow ever shorter. Our mathematical model precisely confirms this pattern, and the outlook for the coming year offers no consolation. One might ask, what should you expect? Regrettably, the answer is clear: nothing promising. We are already entering a new reality to which it is becoming increasingly difficult to adopt. Yet instead of focusing on investigating primary causes and devising solutions, we continue to engage in pursuits that have little to do with what is truly needed for the survival of our civilization. This is a deeply troubling testament to humanity's collective myopia. Unfortunately, this is the objective truth. Allow me to move on to a more detailed geospatial outlook. First and foremost, it should be noted that the United States of America will not be able to evade the consequences of intensifying cataclysms. This is inevitable. The escalation of cataclysms on North American continent will continue to mount. Admittedly, at this moment, I do not observe imminent criticality at the Yellowstone supervolcano zone. Still, one must not trifle with such entities, and it would be rash of me to offer any guarantees. We're recording certain shifts in geophysical parameters, and there is a likelihood that they will intensify. Nevertheless, the principal epicenter of geodynamic risk is moving to another continent, where the risk of adverse process dynamics is currently heightened. Particular attention should be paid to the territory of China. According to our calculations, the approaching climate changes will exert an unprecedented influence on the region's industrial infrastructure and production capacities. These processes are inexorable. This is not merely a challenge to one specific country. It is the onset of a new era of global transformations, the repercussions of which, regrettably, will be felt by all of us. Allow me to draw your particular attention to the situation unfolding on the Arabian Peninsula. Floods and hurricane-force winds are already exerting considerable pressure on the region's infrastructure. In addition to the climatic anomalies and intensifying atmospheric phenomena we are currently witnessing, our calculations indicate an impending intensification of seismic activity in the Arabian Peninsula. Over the past year, the number of earthquakes with a magnitude greater than 3 in this area has doubled, which means that the emergence of powerful earthquakes in the region is merely a matter of time. Once the rapid escalation of higher magnitude seismic activity begins to affect this region, the consequences may prove extremely severe. Future geodynamic changes on the Arabian Peninsula are inevitable, and it is our professional duty to warn the scientific community and the public. I must say, I sincerely pity Dubai. It is a magnificent city, yet its future is predetermined. Today, I would also like to draw your attention to the extremely dangerous situation unfolding in the Mediterranean region, particularly in Italy. While many have their eyes fixed on Yellowstone, which according to current forecasts does not demonstrate critical indicators for the coming year, the situation with the Italian supervolcano Campi Flegrei looks far more alarming. This volcanic complex is exhibiting signs of extraordinarily rapid escalation in seismic activity, and the year 2024 has been especially noteworthy in this regard. Please take a look at the graphs from the November 2024 Campi Flegrei Bulletin, published by the Naples section of the Vesuvius Observatory. These graphs illustrate the trends of key seismological parameters at the Campi Flegrei since 2005. Over the last 12 months, the region has recorded 6,547 earthquakes, which is nearly an 8% increase over the previous year. The majority of these earthquakes occurred at depths of up to 3 kilometers, that is to say 1.9 miles, with a maximum depth of approximately 4 to 5 kilometers, again 2.5 to 3.1 miles. These shallow earthquakes are particularly concerning because their limited depth indicates rising pressure in the magma reservoirs. Furthermore, such events can serve as precursors to larger events, including volcanic eruptions or major fault ruptures, since shallow seismicity often signals instability of the surrounding rock strata near the surface. Since 2019, the region has witnessed an increase in the frequency of earthquakes with a magnitude of 3, which further confirms the escalation of activity. In addition, the total energy released by the earthquakes from 2019 to 2024 has already surpassed that of the most substantial bradyseism on record in 1983. Bradyseisms are vertical movements of the Earth's crust. Data on the rate of ground uplift in the zone of maximum deformation confirm the ongoing process of bulging in a particular area near Pozzuoli Rione Terra since 2007, which is clearly associated with the intrusion of magma. At Campi Flegrei, we also continue to see a steady increase in other thermal and geochemical parameters. These processes indicate energy accumulation within the Campi Flegrei system. Italy should brace itself for serious consequences, and the rest of the world should certainly not grow complacent. Let us be honest. The events we are describing are inevitable. We must confront them not with panic, but with a philosophical understanding of nature's laws and the reality before us. This is precisely why, upon analyzing the global data, I emphasize the importance of Italy's preparedness for what may come next. I now feel it my duty to convey those observations that elicit the greatest alarm, namely the geodynamic processes underway in the region of the East Siberian platform. Unfortunately, due to the actions of a single individual, we possess only limited information and must rely primarily on indirect indicators of what is occurring in Siberia. Yet even the data we have point to a stable trend of increasing pressure on the East Siberian platform from below owing to the ascent of a massive magma plume. Judging by the marginal deformations and the emergent geodynamic processes, we can state with confidence that the plume's pressure on the platform is extensive and significant. The uplift of the platform has already begun. This is without question a profoundly tragic trend. However, there is another aspect of this phenomenon that merits attention. The current activity of the Siberian plume may serve as a kind of safety valve within the global geodynamic system. Our research shows that the ongoing redistribution of mantle stresses is contributing to a slight reduction of pressure in the magma reservoirs of other supervolcanic systems. Let us now address the mechanism of platform uplift separately. Traditional models assume that as mantle plumes rise and heat the overlying lithosphere, they should create a substantial surface uplift of up to 2 kilometers, about 1.2 miles, in height before magma breaks through. However, there were no geological indications of such dramatic uplift in the area of the Siberian traps, which were formed as a result of a magma plume intrusion 250 million years ago. A study published in 2011 in Nature by geologist Sobolev and colleagues from institutes in Russia, Germany, and France presented a fundamental change in our understanding of mantle plume dynamics. Based on their examination of magmatic rocks from the Siberian traps, they established that instead of rising like a bubble, the plume gradually eroded the lithosphere from below. When the erosion at the contact zone between the molten plume material and the upper mantle rocks reached a depth of 50 kilometers, about 31 miles, large-scale lava outpourings and eruptions at the surface began. The present activity of the plume likely follows the same mechanism. Therefore, we should not expect a significant uplift in just one area at the initial head of the plume's intrusion. Nevertheless, this does not rule out the possibility of extensive regional uplift of the entire East Siberian platform by some amount. Even a micro-scale uplift of this sort could ultimately lead to a macro catastrophe. Geological data indicate that the intrusion of a magma plume in Siberia approximately 250 million years ago at the boundary of the Permian and Triassic periods led to the largest mass extinction event in Earth's history. To grasp the scale of the potential threat, I will offer a comparison. A possible magma breakthrough in this region could have consequences 1,000 times greater than the combined effect of hypothetical eruptions at Yellowstone and Campi Flegrei. Any specialist in geodynamics would confirm the gravity of these observed processes. From a scientific standpoint, we are witnessing a classical scenario in the evolution of a large-scale geological event, the intrusion of a gigantic magma plume. If humanity does not undertake measures related to volcanic engineering in Siberia, there are only two possible scenarios. The first is a sudden breakthrough of the Siberian plume and the rapid extinction of humankind. The second is a gradual emergence of lava at the surface, similar to what transpired 250 million years ago, bringing about a slow, agonizing demise for the population of an entire continent. The key question is not whether one of these scenarios will occur, but rather the scale. Will the consequences be confined to one continent, or will they affect all of humanity? We find ourselves in a rather ambivalent situation with the East Siberian platform. On the one hand, our calculations show that the lithospheric block in this region possesses exceptional strength and a significant reserve of deformation resistance. These characteristics provide some hope that over the coming year, the platform will withstand the plume's onslaught. However, for the past year and a half, we have not had accurate data on the dynamics of geological processes in this area, which greatly complicates our ability to forecast events. At the same time, we must not forget that a risk of the breakthrough in the Mariana Trench, an issue we have discussed repeatedly, has not diminished. Such a breakthrough may unfold according to a scenario analogous to what humanity observes on Mars. Meanwhile, it remains unclear which of these processes will reach a critical point first: the exhaustion of the East Siberian plate strength, or destabilization in the Mariana Trench region. Which of these two scenarios is better or worse is quite literally up to you to decide. I must note that the answers to many of these critical questions will likely emerge in the coming years. The ongoing processes demand the immediate attention of the international scientific community and coordinated efforts in monitoring and risk assessment. However, as you know, humanity is now confronted with a situation in which, due to the decisions made by one individual, access to critically important geological data in the East Siberian platform area remains quite literally blocked. For a year and a half now, we have been unable to conduct comprehensive monitoring of subsurface processes in this region. At the same time, the Siberian magma plume could erupt at any moment. This inaccessibility, brought about by the actions of a single individual, is already affecting billions of people worldwide. Unfortunately, these repercussions will only intensify without timely measures. Time works against us, and each day of delay increases risk for all of humanity. It is important to understand that planned, controlled degassing of the Siberian magma plume could become a vital instrument for reducing subsurface pressure and preventing catastrophic events in Siberia and around the globe. But will anyone undertake such efforts? Frankly, I doubt it. Those responsible are far too occupied with geopolitics. It should also be noted that in light of the information presented, there is a possibility that under exceptionally favorable circumstances, humanity's fate might merely culminate in the onset of a global glacial period, based on the previously discussed scenarios of the Siberian plume's breakthrough. This process could begin significantly earlier than traditional climate models would otherwise suggest. I have already said, and will continue to say, that the current historical moment demands a radical re-evaluation of priorities by the international community. Military conflicts and geopolitical confrontations now appear counterproductive as humanity stands at a critical juncture. Any delay in addressing global geodynamic challenges may lead to irreversible consequences. Regardless of the desires of particular individuals, all will eventually come to this realization. Indeed, most people already want these conflicts to end and expect leaders to devote serious attention to resolving climatic and environmental issues. According to our outlook, the time frame of a relatively stable life spans approximately 4 to 5 years. Even this scenario should be regarded as optimistic, and it is impossible to guarantee with absolute certainty. We must acknowledge that the world has entered a period of fundamental transformation. The intensity of geodynamic changes is increasing exponentially. Practice and experience demonstrate that in the face of severe natural disasters, people are generally left to fend for themselves and rely on their immediate surroundings. Providing the public with sound strategies for how to behave during natural calamities becomes a critically important foundation. Even if we cannot do more, at least this measure can save many lives. It is therefore essential to be prepared and possess basic survival skills, as well as a clear understanding of how to act under the extreme conditions of intensifying cataclysms. The events to come demand greater composure, heightened vigilance, and a readiness to avoid unnecessary risk. Pay attention to the warnings of rescue services, and if need be, evacuate dangerous areas in advance. This may save your life. Remember that your awareness and preparedness in the face of cataclysms can safeguard not only you, but those around you as well. Take care of yourselves. Your life is worth it.